Hi, my name's Adam and I'm tackling question 5, which is to explain the difference between injective, surjective and bijective functions. I'm going to do this in this presentation by utilizing examples. So let's begin with functions. So functions are a rule which basically assigns one input to a single output. So we have an input x to an output y. X is also known as the pre-image of y, and y is known as the image of x, basically because they're an image of each other because they're related by the function. So what this means is that for each element in x in the set x and each element y in the set y, we can say that f of x is equal to y. So we have value x, we plug it into the function, and the result of plugging into the function will equal y. Now a function can equal something like x plus 1. That's all it is. So you get x plus 1, the result of that is y. Very simple. So an injective function, which is our first type of function, is basically a function that's defined by x1 is not equal to x2, thus f of x1 isn't equal to f of x2. Now, when we're saying f of x, we are saying these values here, y1, y2, y3. So it's basically the values that have been, you've got an x value, you've applied the function, and the result is f of x. So the function applied to x, so it's y1, 2, and 3. So to prove that, we've got an example here. We can have a function that says f of x is equal to 3x minus 4, and to prove that we can say the contrapositive of it, so the opposite of this definition here. So we can say that f of x1 is equal to f of x2, therefore x1 is equal to x2. So we get our example here, we say f of x1 and f of x2, so that's 3x1 minus 4, 3x2 minus 4. We can use simple algebra, cancel out the 4's. We are left with 3x1 is equal to 3x2, and we can divide either side by 3, and the result is x1 is equal to x2, thus satisfying our injective proof. Now we can look at this on a graph and we can grab our value of x, which is 3, and its corresponding y value, which would be 5. Now we can see that one value maps to one value here, and if we look along the graph, there's no x value, other x value that maps to 5. There's no other x value here that maps to 5. That touches on the line. Now, with an injective function, there's also a rule that we can't have an extra x that attaches to the same y as another x. But another rule that we can have is that we can have a y just floating around by itself. So a surjective function is our second function, and basically definition, it means that for every y value there has to be at least one x value that's been mapped to it. This means that there can't be a y value that's alone, unlike an injective. However, there can be a y value that's mapped by two different x values, like we said before. So for example, we've got x3 and x4, and they both map to y3. Now the definition for this is for all y, so for all values in the set of y, so all here, there is at least one x such that f of x satisfies equal to y. Now we grab a random example here, f of x is equal to x squared. We have some values plugged into that. Now we can grab two of those values and we can say 2, we can grab the x value 2, its corresponding y value is 4, and minus 2, corresponding y value is also 4, and we can have that. We can have two x values equaling the same value, therefore it is surjective. Remember, we can't have that with an injective. Our last function is a bijective function, so that's injective and surjective put together. Now, basically, with a bijective function, it's a perfect one-to-one correspondence or correlation between each element in the set. So, to satisfy the injective function part, there can't be any more than one x value mapped to a y value, so it's just like an injective. Now, to satisfy the surjective part, there can't be any value left alone, and all y values have to be used by an x value. They have to be mapped to one, thus obtaining a bijective function. Now, an easy example of a bijective function is f of x is equal to x plus 1. So for that, we can give some x examples, so 0, 1, 2, negative 1, etc. We can grab first one 0, and its corresponding y value is 1. So we have 0, and we have 1. And if we keep going up the graph, we have x is 1, y will be 2. It just keeps going up and up, or down and down, and they keep matching values on the x to the y. So what this is saying that it's one-to-one relationship no matter what, and that's proving a bijective function. So thus we have all three functions. Now to conclude, an injective function can't have more than one x value mapped to a y value, but it can have a lonely y value. A surjective function has to have every y value mapped to at least one x value, but it can't have a lonely y value. And a bijective function are these two functions combined rather. And that's my presentation, so thanks for watching.